Welcome to qnawire.
We're going to calculate the enthalpy change in kilojoules associated to the conversion of ice into water vapor at two different temperatures. So, first of all, the sign of the enthalpy is going to be positive because this is corresponding to an endothermic process because we're absorbing heat from the environment to melt the ice. So, the information that is given to us is that we have 25 grams of ice. The initial temperature is going to be equal to minus 4 degrees Celsius. The final temperature is going to be equal to 109 degrees Celsius, and we're going to end up with water vapor. We know that the specific heat for ice is going to be 2.09 joules per gram degree Celsius or Kelvin. Both are correct in this case because since we're dealing with changes of temperature, we can use either units. The heat capacity of water is equal to 4.18 joules per gram Kelvin, and the heat capacity of the vapor or for the steam is going to be equal to 1.84 joules per gram Kelvin. Other information that we have is that the enthalpy of fusion of water is equal to 6.01 kilojoules per mole, and the enthalpy of vaporization of water is going to be equal to 40.67 kilojoules per mole. So we can proceed by combining the mass and the amount of mole in our calculations. In order to do that, let's calculate first the amount of mole of water that we are going to have. This is going to be equal to 25 grams divided by 18 grams per mole, yielding 1.389 moles of water. And to know what is going to be the value for the delta H, in this case, in the units of kilojoules, the result will be the contributions for each of the different phases. So the first thing that we need to consider is the mass of ice times heat capacity of ice times the delta temperature for ice, plus the amount of mole of water that we're going to have times the delta H of fusion, plus the contribution of the mass of water that is going to be the same as the mass of ice, but I'm just putting this label to identify the different processes, times C of water times delta T of water, plus amount of mole of water times delta H of vaporization of water, plus the mass of the vapor times heat capacity of the vapor times delta T of the vapor. So as you can see, it is a quite long equation. So we know that delta T for the ice is going to be equal to 4 degrees Celsius, which is the same as 4 Kelvin. We know that delta T for the water is going to be equal to 100 degrees Celsius because we're going from 0 to 100 degrees. So final minus initial, 100 minus 0, 100, which is going to be the same as 100 Kelvin. Remember that this is just the same because these are changes of temperature. If you convert the quantities to Kelvin first and then take the difference, you're going to find these results. So instead of putting an equal, let me put an arrow to mean that they're slightly different, right? That this is just the value for delta T. And finally, for the vapor, we know that we're going to begin at 100 degrees Celsius and we're going to end up at 109 degrees Celsius. So the change of temperature is going to be equal to 9 Kelvin or 9 degrees Celsius. Again, both are correct since we have changes of temperature. So now the only thing that we need to do is to replace the values. So the delta H is going to be equal to mass of ice, 25 grams, heat capacity of ice, 2.09 joules per gram Kelvin, times delta T for the ice, that is going to be 4 Kelvin. We need to convert this quantity from joules to kilojoules for the result to be directly in kilojoules. So we know that in 1000 joules, we're going to have 1 kilojoule. The next contribution is going to be amount of mole of water. We said that was 1.389 mole times delta H of fusion of water, that is 6.01 kilojoules per mole. Plus, now the next term, mass of water, again 25 grams, heat capacity of water 4.18 joules per gram Kelvin, delta T is going to be 100 Kelvin, and the conversion factor of joules into kilojoules. So 1 kilojoule is going to correspond to 1000 joules. Next term, we are going to have amount of mole of water, 1.389 mole, times the heat of vaporization of water, which is 40.67 kilojoules per mole, plus the mass of the vapor, 25 grams of vapor, heat capacity of the vapor, or the steam, 1.84 joules per gram Kelvin, times delta T for the vapor, 9 Kelvin, times my conversion factor, 1 kilojoule divided by 1000 joules. So I'm going to, just for sake of completion, let's calculate all of the terms and then we're going to add them up. The first term in our equation is going to be 0.209 kilojoules. The next term is going to be 8.34789 kilojoules. The next term we're going to have 10.45 kilojoules plus 56.49063 kilojoules plus the last one, that is 0.414 kilojoules. So with this, we're done with the problem. We just need to add everything up, and the enthalpy for this process is equal to 75.91152 kilojoules, which is approximately 75.91 kilojoules. So I'm going to give you both the whole result and just rounding up to four significant figures, but you can put as many as your professor requests. So that would be all. Thank you very much and have a good one.